This is the training for WellSeeker Pro WITS and WITSML functionality. WITS and WITSML stand for Well Site Information Transfer Specification and Well Site Information Transfer Specification and Markup Language, respectively. Effectively, all they are is a defined method of transferring data at the well site to other computers. Either WITS or WITSML data can be imported into WellSeeker Pro in real time, and that data can then be utilized to populate various dialogues and features within WellSeeker Pro. This course will cover each of those functionalities individually and how that data is pulled in, utilized, and can then be output. In order to utilize the real-time WITS and WITSML functionality, you need to have an actual wellbore, a survey under that actual wellbore, and have access to slide sheets, which requires an already input BHA. So I'm going to open up my survey. This then gives me access to the slide sheet dialog. And from here, this is where the majority of the WITS and WITSML dialogues and functions can be accessed. Once you've got to this stage, you then need to start thinking about how you're pulling in your data. Are using WITS or WITSML? The difference between these is that WITS pulls in data locally. If you're at a rig site, it takes data from a rig's computer and you have a physical cable connection to that rig computer, and it sends information directly to your WellSeeker computer. WITSML is technically, you don't require a cable for it. All you require is an internet connection. And how that works is whatever the initial source of data is, sends the data to a server via the internet, and then you can then access the information from that server also via the internet. So these are the differences between WITS and WITSML. These are your import methods. Which one of these are you going to go ahead and use? If you're using WITS, then you first of all would check your WITS mapping. I'm going to minimize the slide sheet. And if we go to Tools, WITS mapping. Within the WITS mapping, we've got a number of columns. The port number, which you don't need to pay attention to. Record ID and field ID are critical. And then you've got the internal mnemonic and table name. Internal mnemonic is how WellSeeker identifies the data type, in this case the measured depth for the bit, and the table name. So this is the physical table within the WellSeeker Pro database that any WITS information for that data type will be stored to. The user should check this WITS mapping prior to setting up any WITS connections. The record ID and field ID that we have in place here are the WITS 0 standard record ID and field IDs. The record ID and field ID should match those for the data type that the person outputting the WITS data has at their end. We have to check that the transmitter computer and our computer have the same WITS mapping. For example, for whole measured depth, we would have to ensure that the transmitting computer is transmitting on record ID 01, field ID 10. If it's not, we would have to adjust our record ID and field ID accordingly to match what the transmitter is using. The point to be aware of is that within our slide sheet, the hook load max is what's used when populating the pickup, slack off and rotating weights within our slide sheet. Something also to be aware of on the back of this is that Payson and Topco often outputs the hook load average and weight on bit average values on the hook load max and weight on bit max channels. So be aware of this and prepare to change the WITS mapping as required if you come across this as an issue. Something else to be aware of, there are no standard mappings in WITS for raw survey values BX, BY and BZ, i.e. your magnetometer X, Y and Z values. So this is something which will need to be double checked prior to receiving survey data if you're receiving raw survey values. Once the user is happy with their WITS mapping, that it matches the person sending the data's WITS mapping, you can hit apply and close. And now open up my slide sheet again. For WITS connections, once we've set up our WITS mapping, you would then go ahead and look at your WITS data reader. You can either access that from the toolbar here, or go to Tools, WITS Data Reader. This opens up the WITS Reader dialog, which I'll explain to you just now. This is effectively where you establish the connection and you can see the raw data feed coming into WellSeeker. There are three types of connection options within WellSeeker Pro for WITS. You have a serial connection, which would be UDP and TCP unchecked, and the serial connection is in relation to the type of cable that you have the connection of data with, i.e. you've got a serial cable, and that will be plugged into a COM port on your computer. Once you've plugged it into your COM port, you can select from the drop-down menu and select the physical COM port that it is connected to. Once you've selected that correctly, you also input the baud rate that the data is being transmitted on. You'll be able to find out this information from the person transmitting the data. So those are the two things you need to select when you've got a serial connection. If you've got a UDP WITS connection or a TCP WITS connection, you would select either of those respectively. A UDP and TCP WITS connection is a network-based connection. So normally this would come via an Ethernet cable on a local network. If you're running UDP WITS, all you need to know is the port number that the data is being transmitted on over that network. For TCP WITS, you need both the port number the data is being transmitted on and the IP address of the computer that is transmitting the data. I'm going to show you how to connect. In this case, I'm going to use a UDP WITS connection. I'm going to enter in my port number that the data is being transmitted on, and then I'm going to hit Start Reading. WITS Reader started on port 3000, and when you are receiving data, you will see it update within the window here. When I want to stop reading data, I would hit Stop Reading. Dump Queue and Test Data buttons don't do anything at this time. The Clear WITS Data button, this actually physically deletes any saved WITS data from your database tables. So that will remove it entirely. The Save Survey and Toolface Data checkbox allows you to save your survey and toolface WITS data, and it saves them to specific WITS survey and WITS toolface data tables in the database. If you have this unchecked, then it does not save survey or toolface data to the database. A point to note is that no WITS data is saved to your database unless you have a specific server second database setup. And I'll talk you guys through how to do that slightly later on. But effectively, no WITS data gets saved unless this Save Survey and Toolface Data checkbox is checked, and it only then saves survey and toolface data. It doesn't save any of the rest. The reason behind this is if you're saving all of this WITS data that's coming in, it rapidly increases the size of your database. Pause messages. So what this does is it literally pauses your window updating here. In the background, you're still receiving the information, but it just stops this window updating. If you uncheck it, it will then continue to update. Send data handshake. This you would only have checked, I believe, if you're running a Neuralis MWD system and you're receiving the WITS data from Neuralis. In all other instances, you would have this unchecked. This is the well and survey that you currently have open. So this effectively is the well and survey associated with any WITS data that you are storing. I'm now going to stop my reader. UDP WITS reader successfully stopped, and so we are no longer receiving WITS data into WellSeeker Pro. The only option I haven't covered so far is this Send Data to Server. When it's unchecked, your WITS information purely remains on your local database computer. If you check Send Data to Server, you're currently receiving WITS data, and you also have a IP and port number input for a server database within your real-time data exchange window, those credentials will be utilized, and any WITS information you're receiving will be forwarded on to that server database. So effectively, you have a means of taking local WITS data, pulling it into your computer, and then pushing it back to your server database of your company. If you have Send Data to Server selected and the IP or port configuration details are incorrect and unable to establish a connection, this is the warning message that you will receive. If you have correct IP and port configuration settings input in the real-time data exchange, this is the message you will receive every time a successful update is pushed to the server. Uncheck that. So that is the WITS reader. This is effectively where we set what type of WITS we're getting in, the credentials for those, a few options around that, and we can visually see when we're receiving or not receiving WITS data. So that's how we can pull information into WellSeeker Pro through one of the import methods, that's WITS. The other option is WITSML. To get to WITSML, you can either go to this dialog on the toolbar or to Tools, WITSML Data Reader. They do the same thing, they both open this WITSML comms dialog. In order to pull in WITSML data, you must have valid login credentials for a WITSML server, i.e. a server URL, a username and a password. As well as those credentials, you must know what type of WITSML server connection it is. The options are 1.3.1 or 1.4.1. The majority of WITSML servers will use 1.3.1. Once you've input your credentials and the type, you would hit Test Connection to check connectivity. And in this case, I haven't got any information input, so at the first stage of the checks, it's basically said we've got an invalid URL. Now that I've input some credentials, if I hit Test Connection again, it will say the connection is successful or not, depending on whether you've got the right login credentials. If I delete this, for example, hit Test Connection again, the request was failed. So effectively, if you're missing an input, it will tell you. If you successfully connected to the server, it will tell you. And if you haven't managed to successfully connect, it will also tell you. Once you've tested connection and you've successfully connected to the WITSML server in question, then you could go ahead and select the Load Wells button. This will load up all of the wells from your WITSML server, and from this point you can then select which specific well you are interested in by scrolling up and down the wells listing. And under each individual wellbore track, you can then also view the trajectories and the logs. The trajectories will be your survey information, and the logs will be the various different parameter inputs, whether that be depth, block height, hook load, whatever. And you can either pull these in by depth log measurements or from time log measurements. And the input type you're going to want for WellSeeker Pro is time log measurements. So you would select all of the relevant feeds that you want for time-based logs. And if you're pulling in surveys, you would select the trajectory log as well. Once you've done that, you would go ahead and set up your curve mapping for that particular set of WITSML log data. And the way that we achieve this within WellSeeker Pro is on the right-hand column here, you've got your standard WITS mnemonics. And in here on the left, you've got your WITSML mnemonic. Now, the reason why we don't have a pre-designated WITSML mnemonic is that WITSML does not have a standard naming convention for all of these different parameters. the user can set these to whatever they like. So they could literally call survey measured depth Dave or cat. They could call it literally whatever they wanted within WITSML. So what we have to do is match what is in WITSML with a predefined WITS standard definition of a data parameter. So in this case, it's already managed to map any matching ones from the WITSML trajectory feed to match exactly our WITSML feed. Next, if there are any feeds from WITSML, we would have to then select them to the one that they correspond to in WITS 0 standard. So in this case, record 0108 and 0110 would correspond to bit measured depth and hole measured depth in your WITS 0 mapping standard. So you can quickly see how we need to build up this mapping. Effectively, this defines what the WITSML mnemonics are and tells WellSeeker what to do with them based upon how they were treated if they were WITS 0 mappings. Whenever you close your window, it will save this curve mapping that you used the last time you were running WITSML in the dialog. So you won't have to reset this every single time that you close the dialog itself. Once you set up your mapping, you would then hit Start Reading. It's going to then update your selected data information with your well bore, the selected log, and the selected trajectory. In the bottom here, you will have an update time that was received, the query time it takes, and then the time from the WITS server that was actually the WITS server was last updated. You can also see the update in our messages window here saying that we're getting WITS ML data, read is successful. And you can also send data to server. This is the same functionality that you would have with WITS 0, where you can push any received WITSML data in real time back to the server. It functions in a very similar way. If you check it, you'll see update completed with no critical errors. So very similar functionality to the WITS data reader. However, this pulls information directly from a server, which we then have to map to WITS 0 mnemonic values. And then we can start reading it. In addition to this functionality, you can also select the correct level of the tree of information and then select Pull to File to pull down information direct from the WITSML server to file format. I'm going to stop reading and close my dialog. So we've covered both of the potential data input methods in WellSeeker Pro. We've got WITS and WITSML. You set up the relevant data reader for the import method that you're wanting to use. And once you're physically receiving data, we then need to know what we can do with that data. So that's what we're going to go ahead and cover now. We're going to look at all the functionality that pulling that data in unlocks for us. Now that we're actually receiving WITS or WITSML data feed into WellSeeker, the first thing I would check is my rig state settings. That could be accessed from either this rig icon on the toolbar or the tools rig states. This opens up the rig state setting dialog, and this is effectively where the software looks at the WITS or WITSML data feed that's coming in, and you can use that data to establish what status the rig is currently in, i.e. whether it's picking up, running in, drilling, circulating, any number of different statuses for the rig. Where we set that up is we basically have some logic in here that works in a very similar way to like an MWD depth tracking system, where the data from the WITS or WITSML feed comes in, and based upon some user-defined thresholds, it can determine whether you are rotating or sliding, whether your pumps are on or off, whether you are have a flow rate that deems you are circulating or not, whether you're in or out of slips, whether you're on or off bottom, and again, whether you are drilling with weight on bit or not. Okay, so based upon these thresholds and these guidance notes on the logic below, the user edits these so that they fulfill the requirements. We've also got an RPM buffer. So this deduces whether you are sliding or rotating based upon the RPM buffer size, which is the number of values you have received for RPM, and this threshold number. So in this case, if we had 9 consecutive values stored, 3 of those would have to be above an RPM value of 50 for it to be considered rotating. If that was not the case, then it would be considered sliding. Okay, so that's what the RPM buffer size and threshold mean. So in this case, I don't have a live WITS feed coming from a rig, so I'm going to use our simulator to simulate WITS or WITSML data feed coming in to WellSeeker. So I'm just going to go ahead and start that with rotary drilling. And in this section here, you can see your current WITS data that's come in. Okay, so in this case, this is simulated data, but you would also see your WITS or WITSML data feed information populate within these cells here if you've received them. You can also see the current rig state that WellSeeker has deduced based upon these values and these thresholds and logical rules. So right now, it realizes that the rig is rotating, it's out of slips, it's moving down, it's on bottom, the pumps are on. So it is logging drilling at this time. You can also see the RPM buffer updating what looks like every couple of seconds here. So what is the use of defining what the rig is doing based upon our WITS data? Well, one particular use for that is that we can auto-update our slide sheets. To do that, you would either go to your settings and check the auto-populate parameters and auto-populate slide sheet, or you can do it from the toolbar with this green button, and that selects both of those options we just looked at. You'll see now that it's updated the date, the start time based upon when we pressed our green button or activated auto-populate slide sheet, and it starts immediately accruing depth based upon the start depth and the course length. It's also pulled in the state, and it's auto-populating our drilling parameters here based upon the WITS data that's coming in. You can see here so far what's been populated: the weight on bit, flow rate, RPM, ROP, torque, on bottom pressure and temperature. You'll notice the pickup weight, rotating weight, slack off weight and off bottom pressure have not been filled in yet, and that is because we are in a drilling activity right now. For these to be populated, there must be an off bottom event occurring. And in the case of pickup and slack off, there must be no rotation at that time as well. So whilst we're getting some data from our simulated WITS input, we'll go and look at a couple of the options we've got available to us. We have record connections data. This effectively, every time we get a connection, if you have this option checked, it will record the connection information. So if I go back to our rig states dialog, these timers down here are effectively your pumps on time, and then we've got sections here for in slips, off bottom and survey. And these basically build up our history of what happens during the connection phase, i.e. when we pick off bottom from drilling and when we go back to bottom for drilling again. So anything that happens between off bottom and on bottom event gets considered in our connections analysis. In addition to populating your slide sheet and recording connections data, we can also view the incoming WITS data on our rig gauges. Again, that can be accessed from the toolbar or tool real-time gauges. In addition to this, we can access the DD dashboard, which can be accessed from the toolbar using that icon, or the directional driller's dashboard under tools. Okay. The information that comes in via WITS are obviously our gauge readings on the left-hand side of the panel here, as well as our drilling parameters chart and the inputs on the right hand section here. This is all populated by WITS. The rest of the functionality within here is covered in a separate training video dealing specifically with the directional driller's dashboard. But this is just to show you that your WITS data provides real-time oversight within the directional drilling dashboard. So I'm going to let this WITS data accumulate for a few connections, and we'll have a look at the resulting data, and you could see effectively how this then becomes a really useful tool. Okay, so now we've got a couple of stands of rotation, and we're partway through a stand of sliding at the moment. So effectively, what this does is it again links back to our DD dashboard, and we can see that we've got a populated parameter history. Based upon the parameters, that updates your slide sheet with the auto-populate slide sheet function turned on, and that in turn updates our directional driller's dashboard with projections, real-time anti-collision, and also your slide tool face rows. So all of that features in really nicely, and is a great RTOC tool for keeping track of your wells data. I've opened up another example here to showcase the slide analysis. So effectively, the slide analysis, for it to function, requires the user to have save, survey and toolface data checkbox activated, i.e. we need toolface data saved on the database for it to physically be viewable. Next, you select a sliding line on your slide sheet, and then you go to Tools, Slide Analysis, or you can select the Slide Analysis toolbar button. This opens up the Slide Analysis dialog. Within here, you have a red line, which is your effective toolface. All of the green are your individual toolface recorded via WITS. If you go to File, you can go ahead and export that data to Excel format. And it'll give you a date, time, toolface, and effective toolface for that particular slide interval. Again, this will be dependent upon the line of sliding that you have selected. When the record connection data option is checked within settings, and then you have recorded WITS data over connections, you can then go to Tools and Connection Analysis, and this will open up the Connection Analysis dialog. Now, we've only got one connection here worth of data between 2 points in a slide sheet, but effectively what you get over the entirety of the slide sheet is for each connection depth, you get a time breakdown and the depth of that connection, and it breaks it down into connection time, the survey time, reaming time, and then an average time throughout. So you get very quickly an overview of where the time for your connections is being eaten up and where the areas for improvement could be. So we've looked really at how the WITS or WITSML input data can be utilized to fill out your slide sheets and populate your parameter data, and that information can then be utilized in other parts of the software with your gauges in the DD dashboard for RTOC purposes. And one of the benefits of having your slide sheet auto-populated is because your daily reporting feeds during drilling operations purely off of your slide sheet, you can pull all of that information into your daily report. Effectively, the DD has to click one button to get his time breakdown and all his parameters into his daily report if he's utilizing the WITS data. It also gives a standardization of how you pull in information into your slide sheet, whereas there may be human variability between different directional drillers, for example. So something we haven't touched on yet, beyond the slide sheet and drilling parameters, is surveys. So you can also auto-populate surveys based upon WITS or WITSML data. The way of going about doing that is within your settings section, you've got a WITS survey options. So first thing, if you want to have WITS surveys checked for, you want the software to be waiting for a WITS survey to come in and for it to actually react to that, you have to have this check for WITS surveys option checked. If it's unchecked, it's not going to do anything. Even if you receive a survey via WITS, it will not do anything. Next, we have the survey type. So you'd choose whether the survey you're going to receive is either a calculated survey, i.e. measure depth, inclination, azimuth, or as raw accelerometer and magnetometer values. Okay, in this case I've got Inc and ASI selected. If you had the magnetometer accelerometer GX, GY, GZ, BX, BY, BZ option selected, you'd need to verify the magnetics units the information is coming in as, the accelerometer units, and also the QC parameters that would come in there. We also have auto send survey email, auto accept surveys, use bit depth as survey depth. So these are all additional options so that when you've received a survey and you've accepted it, this will automatically send your survey email template, and we'll look at that in a moment. This will automatically accept the survey without even notifying you that the survey has come in. We wouldn't recommend this option being selected. However, it could be utilized in a personless remote drilling scenario. And use bit depth as survey depth, again, in a personless operation. If you don't have someone on hand to verify the survey depth, this is a way of keeping it uniform, and then the survey depths can, at a later date, have the offset taken off them, just so you have a standardized way of doing it. But again, would not recommend using this. Include bit projection in survey email. We'll look at that when we look at the survey email template. And again, attach survey listing to email. All three relate to this survey email option. Okay, so next we go to the survey email template in Tools. And this brings up a list of an email body and a title that will get sent every time you get a survey. So this is based upon, we haven't had any surveys yet. So the information in place is for our tie-on line for our well. Below that survey information, you've got your well, rig, customer, the survey, how far your survey point is off the principal plan, and then you've got a bit projection based upon a straight line projection, as well as some other pertinent information. You can set up a pre-designated list of recipients for this. So for example, just going to put in a couple of made up emails here. So you can have example1@email.com. Okay, so you can put them in one at a time like that. Or if you have a long list of emails to put in here, you can do it with not having a space, just putting a comma between it. Okay, and hit add, and that will then add them as separate. So just do one long list, only commas separating the emails, no space or anything like that. And then you could put in a long string of information and put in ultimately as many emails as you wanted in one go. So that's a way of having a recipient list already in place. This emailing list works if you have Microsoft Outlook as your email provider. So when I hit send email, it automatically generates an email ready to send with all the recipients that you had on your list. Good to go. The whole body and the survey listing report attached already. All the user has to do is then hit send. Okay, so that's the survey update email template. So based upon those settings that we've looked at, I'm now going to simulate receiving our first survey. Okay, that should be coming in via WITS now. And once it's received, it will have pulled in the measured depth that came across via WITS, inclination, and the azimuth. Now, I sent a calculated survey, so there's no dip, no HL, no gravity total or tall face or anything like that. So the user has the option here to accept the survey, to ignore it, or accept corrected survey. So the corrected survey is only a short color correction possibility when you're receiving a raw survey input. So I'm just going to go ahead at this time and hit accept survey. And what this does, if we minimize the slide sheet, is it's actually taken the survey and populated it straight into my surveys table for this well. If I hit save, that will save it to the survey program, and that's all in place. Okay, I'm going to now try and simulate a next survey. So now I'm going to simulate sending a raw survey. I'm going to go and change my survey type to GXGY, BXBY, BZ. I'm going to select the appropriate units, so I'm going to keep that as millivolts, and accelerometer units in G. QC limits I'm going to leave as default, and then I'm going to send my survey via WITS in the raw configuration. And we can see now I've sent a new survey, 300 measure depth via WITS. It's received it, and it's gone ahead and shown me the raw values that I've sent, the measured depth, the calculated inclination on the basis of these values, the calculated raw azimuth on the basis of those values, and it's showing that my dip, local magnetic field strength, are out with QC tolerance based upon my QC limitations here and in reference to my reference values. So we can see they're a long way off. In reality, I would probably ignore this survey. Equally, once it's been run through short collar correction, it gives us corrected azimuth, but it also tells us that the short collar correction, local magnetic field strength, total magnetic field strength, and dip are out of spec as well. So this survey in particular you would ignore. If these fall within QC criteria, they're highlighted in green. So it's very quick and easy for the user to discern whether it's an acceptable survey based upon these raw survey tolerances and the raw survey reference data that is in the database tree, and quickly deduce whether good or bad survey coming in via WITS or WITSML. So that really covers the functionality of WITS and WITSML within WellSeeker Pro. It's a way of pulling in data from the rig site, and you can utilize that to populate your slide sheets, view the information on gauges or on the DD dashboard. Once you've got that information in place there, obviously from the slide sheet it can then be pulled in to your daily reporting, and that will update your daily reporting, which in turn updates your well analytics and KPI information in a quantifiable and repeatable manner. In addition to that, you can also pull in real-time surveys based upon a WITS or WITSML feed. Bearing in mind that the DD dashboard feeds off of the slide sheet and off of the surveys, effectively WITS allows the DD dashboard to be almost autonomous in nature, and is an extremely useful tool therefore for real-time operations centers and remote control and overview. Something that was alluded to earlier on in the video was the storage of WITS data. So as previously mentioned, WITS data is not stored to your database. If you want to store your WITS data proper, you have to save it on a server database, and it has to be a defined secondary server database. And I'll talk you through how you go about doing that. But first, let's just refresh on how you send data back to the server in the first place. You go to Tools, Real-Time Data Exchange, and check that your IP import credentials are correct to send data back to your server. This dialog doesn't have to be open when you are pushing data back to the server, but these credentials have to be correct prior to doing so. Once that's the case, you then go to your either WITS reader or your WITSML reader dialogs and check the send data to server. So any WITS data that you're receiving will now be pushed on to the server. Okay. Right now you can see here I'm not receiving any WITS data, but my last lot of WITS data that I have stored on the database, it's getting pushed back to the server with each of these individual lines. I'm going to uncheck that now, and that would stop sending information to the server. So that's just a refresher. I'm now going to go and look at our server database that the data is pushed back to. And there is a table within the database structure called cur_wits_data, and that's the current WITS data. For each well that is having data pushed back to it on the server, there is an individual row. And this one row exists on a standard database and then gets overwritten every time a new set of data is pushed back to the server. So you'll only ever have one row of data. i.e. you're not storing anything, but this is updating the software with the latest information. And this is what feeds the likes of your DD dashboard, parameters, graph, and your real-time gauges. Now, if you want to store data in a database structure, we don't store it on the main database because that, as mentioned previously, makes that database very large and actually slows down the functionality of your main database. What you go ahead and do is create a second database, and in the case of using AWS as your service provider or your SQL Server database, you would create that under the same RDS. Now this particular bit is more for your IT management guys, so you guys in the field, don't worry about it that much. IT guys, you will have to set up a second database. Then, for your JSON file that exists on the EC2, you would have to go about changing these particular credentials. Okay, there's two in question. You'd have to make sure this transfer WITS option is set to true, and that the SQL database name WITS is set to the name of the database that you want WITS data to be stored in. Okay, and that would be separate to your standard database where majority of information go to, i.e. a standalone database. Once those two options are set up correctly, you would then restart your ICDS server to utilize the JSON, and then whenever WITS data is pushed to the server, it won't get pushed to your main server, it will get pushed to your backup database, and the information will be stored there. Okay, so that's how we go about storing WITS or WITSML information within a WellSeeker Pro server database. That covers the functionality to do WITS and WITSML within WellSeeker Pro. We're now going to go on and go through some quick question and answer and an example exercise. This is the questions section. We're going to read out the question followed immediately by the answer. So if you don't automatically know the answer, pause the video before I read out the answer and go and find out the answer for yourself. So first question, what's the difference between WITS and WITSML? And the answer is WITS is a local data transfer setup using cables to transfer that data, whereas WITSML transfers data to and from a server and is transmitted via an internet connection. So effectively, WITS data requires cable setups, whereas WITSML just requires the internet connection. Next, what's the difference between serial, UDP, and TCP WITS? Okay, so these are all local data transfer setup types, but they differ. Serial WITS is transmitted via a serial cable. UDP and TCP WITS are transmitted over a local network, usually via an Ethernet cable. So different setup credentials are needed for each type, so it's important to know which of these three setups, if you're transmitting WITS, the transmitter is using, so you can input the correct credentials and receive at your end. Next question. If a user wants to store their WITS/WITSML data, how can this be achieved? So the user can only store all of their WITS data, i.e. all of the drilling parameters, everything that's coming in, or WITSML data, to a secondary server database. And this can only occur if their IT department has set things up correctly. So that is the only way of storing all of your WITS data. If, however, you just want to save the survey and tool phase data, the user has a checkbox option within the WITS dialog to save that directly to your local database. Moving on to the exercise. So effectively, this is just your chance to get hands-on and test out some of the WITS or WITSML functionality for yourselves. Effectively, you already need the cables or connection directly to a system transmitting WITS data or connection to a WITSML server. So those need to be in place already. Additionally to that, you need an actual well bore in place with a survey and a BHA included under all of that. Once you have those in place, you can go ahead and open up your slide sheet and then go into the setup in the settings. So for instance, you can select what options you want for your WITS surveys or whether you want to record connection data. So set that all up before actually getting the connection underway. Next is open the WITS or WITSML reader dialog depending on which type you're pulling in. Obviously if you're importing WITS data, open the WITS dialog. Okay, select the correct connection settings and start reading WITS data. And you should see that, or WITSML data. You should start see that populating if everything has been set up correctly. If not, go and change the credentials, make sure you've got everything input correctly. If the input credentials are correct, then have a look at your cable connections or your internet connection respectively. Next, open the rig states dialog and ensure that the WITSML data that you've got displaying on your reader is actually coming in to the rig states dialog, and specifically in the current WITS data section. So you should see that updating as WITS or WITSML data comes in. Next, check your threshold settings within the rig states dialog and ensure that the current rig state is being calculated correctly. If they're not correct, adjust those accordingly to calculate the rig states correctly. Then go back to the slide sheet and select the Auto Populate Slide Sheet green button from the toolbar and watch the slide sheet auto update when you're on bottom drilling operations. Next, open up the DD dashboard and you'll see the WITS/WITSML data updating in real time in the gauges and also on the parameters graph. If you're having tool faces for a slide as well, you'll also see them update on the tool face rows. Additionally, you can open up the real-time gauges to see those come in. And if you have surveys selected for importing with WITS or WITSML, then when a survey is registered by WellSeeker, accept that survey and check that it's been added to your survey table. If you have a server database, you can open up the WITS or WITSML dialog and check the Send Data Server checkbox when you're physically receiving WITS or WITSML data. Then go ahead and log on to your server database and ensure that the WITS data or WITSML data is updating on the server correctly. And you can do this again by checking in your rig states dialog and looking at the current WITS data section. That should be updating, and also by viewing your DD dashboard or your rig gauges, and these should be updated with real-time WITS or WITSML data if the connection has been successful. Throughout all of this, please have a play around with all the settings, get really familiar with the nuances of making changes to the setting, how that affects what's dealt with WITS. Okay, once you've done all this as well, if you have populated your slide sheet, you can then go onto your daily reports and pull that data in as well, just so you really get an idea of how this WITS data is very useful. If at any point you become stuck, please refer back to the video for a refresher. That concludes the WITS and WITSML within WellSeeker Pro training.